So yan sa reservoir problem na tayo. So sa reservoir problem, so ilan yan? Yung una dyan is yung a reservoir discharging through a pipe, no? So discharging through a pipe. Then pangalawa dyan yung to reservoir. Then the last one dyan is yung free reservoir. So, yan. So, ganyan yan. Tatlo yan. So, let us discuss it one by one. So, for a single reservoir discharging to a pipe, no, ang total head loss dyan, matic, is the difference of the tip ng pipe tsaka yung water elevation. So, yan yung magiging head loss. So, bali, the velocity is equals to square root over 2 times GH, no? So, bale, doon lang naman siya galing sa B squared over 2G is equals to H. Diba? Doon lang yan galing. So, for a 2 reservoir naman, connecting, a pipe connecting 2 reservoir, ganoon din naman. Ang difference ng elevation nila will be your total head loss. So, everything is the same dyan naman pag nag-solve ka ng problem. So, sabi ko nga sa inyo, as dun sa hydraulics natin kanina, na everything na may pipe, you can apply Bernoulli's equation. So, here, kung you are confused kung anong mga formula gagamitin mo, then, pag-apply ka ng Bernoulli's equation. So, for bali yan, ang total head loss nito is H. So, bali equal yan. So, yung minor losses, but yung friction losses. So, for a 3 reservoir problem naman, so it's very different. So, hindi mo diyan kaya mag-Bernoulli's equation. So, mayroon diyang separate method din siya on how to solve the specific solve the 3 reservoir problem. So, let us start first doon sa a pipe discharging from a reservoir, or a reservoir discharging through a pipe. Yan, kung sample number 1, a 20 mm diameter commercial steel pipe, 30 meter long, is used to drain an oil tank. Determine discharge when the oil level tank is 3 meter. So, sabi niya 3 meter above the exit of the pipe. So, neglect minor losses and assume F is equals to 0.12. So, yan. Nahanap niya ay discharge. So, U is equals to area times velocity lang naman. So, ang velocity natin sabi is square root of 2G times H. So, area, meron tayong 20 mm diameter. So, pi over 4 times the 20 mm, so 0.02 squared times square root of 2 times the gravitational force na 9.81 times the height na 3 meters. So, the value of U will be 0.024. Aba? Negative 3. So, 0.002124 cubic meter per second. So, ayan yung discharge. So, discharge lang hinahanap. So, may binigay pa na F. So, discharge lang naman ang hinahanap. So, for number 2, ay wala na, pero number 2, next is yung pipe connecting to reservoir. So, bali, yan, may sample problem din na isa. At 2.5 meter diameter pipe length, 2,500 meter ton base water between two reservoir at the rate 8.5 cubic meter per second. What must be the difference in water surface elevation between the two reservoirs? Assume 0.018 for your coefficient, no? So, bale, two reservoir, ang hinahanap ay difference in elevation. So, ang hinahanap ay H. So, may Q tayo na equals to 8.5 cubic meter per seconds. Then, ang diameter natin is 2.5 meter. So, F is equals to 0.018. So, makakuha natin yung H. Kukunin natin yung head loss. Sabi natin, head loss is equals to H. So, total head loss is equals to the difference of elevation. So, that is equals to 0.0826. Then, yung F na 0.018. The length of, may length ba? 2,500 meter. Yan, 2,500 meter. Then, Q of 8.5 squared 2.5 raised to 5. So the difference in elevation H is equals to the difference in elevation is 2.75 meter. So that's for two reservoir problem. So basic din naman siya, wala rin naman siya masyado pinagkaiba sa the knowledge equation. So let us now move on to three reservoir problem. So yan, meron tayong dalawang type ng 3 reservoir problem, no? So kung 3 reservoir problem, meron tayong type 1, then meron tayong type 2. So yung type 1 natin, given yung at least 1 na cube. At least 1 discharge. And may mga iba pang given, then papasolve ang elevation, ganon, head loss. So basta pag given ng may given na sarang discharge, that is type 1. Then sa type 2, as in no discharge is given. Wala talagang discharge. So, yan lang para ma-distinguish nyo agad-agad kung anong type ang gagamitin nyo. So, for type 1, ang steps, no, in solving the problem, say ganyan, no? So, let's say ganyan. A, B, and C. Pag given ang one of the discharge, so doon kayo mag-start. You know? And then, halimbawa dito given yung pipe. So, makakuha mo yung head loss dito. Then, pag nakuha mo yung head loss dito, makakuha mo yung difference nung elevation nito by yan. Then, kumbaga, ang pinaka-idea digde pag solve is kung saan may given, doon kayo mag-start. No? So yan, sabi niya, with known flow in one pipe leading to or flowing out from a reservoir of known elevation, solve for its head loss. So, given dyan, you solve mo yung head loss niya, then determine the elevation of the energy grade line at the junction of the pipe. So, di ba guys, mayroon tayong tinatawag na imaginary junction P dyan. So, yan yung nag-determine kung saan yung flow ng light. No? If the head loss is head loss of pipe B is if the elevation of junction P is lower than the elevation of reservoir B, then the flow pipe will A plus B is equals to C. So, papunta dito yung flow. At kung yan naman ay kung ang P ay mataas sa B, so the flow pipe ay papunta sa D. So, ganyan yung steps in solving the problem in type 1. Then, for type 2 naman, so, for type 2, yan, sabi ko, all properties are given, pero walang Q. So, for type 2 naman ay calculator technique na naman tayo, so hindi natin siya pagtuturan ng pansin. So, let's start this one for type 1. So, type 1 problem, number 1, no? Andyan, 3 reservoir A, B, and C are connected respectively with pipes 1, 2, and 3 joining at a common junction P, whose elevation is 366 meter. Reservoir A is at elevation 993 and reservoir B is at elevation 844. The properties of these pipes are as follow. Yan, ang hinahanap is what is the flow in pipe 3 and cubic meter per second in the elevation of reservoir C. So, ilagay lang natin yung mga given. No, sabi niya, mayroong junction P at elevation of 366 meter. So, elevation nito ay 366 meter. Tapos, reservoir is at 993. So, elevation nito is 993. 933. So, and reservoir B has elevation 844. Yan, elevation 844. So, then, yan, properties of pipes are given. So, a pressure gauge at junction P reads 4950 kilopascal. So, junction P to. Ito yung junction P, no? Yan. Ito yung nasa elevation 366. Yan. So, sabi niya, ang reading daw dito ng pressure gauge is 4,950 kilopascal. So, something na ganyan. Pangalan natin na P prime. So, may pressure siya na, pressure rate siya na 4,950 kilopascal. So, i-convert natin siya into head. So, pressure lang yan. So, i-divide lang natin siya by 9.81. So, makukuha natin ang difference ng P prime sa P. So, tanggalin na natin yung 4950 kilopascal. So, 4950 divided by 9.81, then may difference siya na 500 P prime, may difference siya na 504.59 meter. So, meaning, ganyan ang flow niya, no? Then, yan. Yan. Pag ganyan yung flow niya. So, ang hinahanap natin ay QC, no? ABC. ABC. Para makuha natin yan, yung C, kailangan natin makuha yung head loss at Chi. So, para makuha natin yan, lipat mo natin to, elevation of 933. So, ito yung HF1 mo, then ito yung HF2, then ito yung HF3. Yan. So, yung HF1 mo will equals to 93 minus so, bali yan siya. 93 minus 366 plus 504 so, bali yan. Ang HF1 mo is equals to 933 minus 366. 933 minus 366 minus 504.59. So, HF1 mo is equals to 93 minus 366 minus 504.59, that is 62.41. So, at the same time, ito rin naman, HF2, pwede rin naman natin siyang makuha by 844 minus kaya, no? Ito yung hinahanap natin. So, 844 minus 366 ay no, ito nung na lang yung elevation nito, so 504 i-minus lang natin dito, diba? So ay no, sorry mali. Ito ay elevation yung distance na ito dito. Distance na din dyan. So, tama naman itong ginawa natin for HF1. So, para hindi na tayo maguluhan, gawin na natin 366 plus 504.59 yan. 504.59 plus 366. So, ang elevation nito, elevation is 870.59. So, ang HF2 natin, is equals to 870.59 minus 844. 870.59 minus 844. So, that is HF2 is equals to 26.59. So, Ngayon, unknown yung elevation ng HF3. So, makakuha na natin ngayon yung mga Q, ano? So, makakuha natin yung Q1. So, Q1 is equal to HF1, which is yung 62.41 is equals to 0.0826 times 0.018 times the length. Length ng type 1 is 1,500 meter. Q1 squared over the diameter niya is 600 mm. No? So, ang Q1 natin is equals to 0.4. So, ang Q1 natin is 2.17 cubic meter per second. And then, ang Q2 natin, gamitin natin yung rentas nito. So, yan ay 26.59 equals to 0.0826. Ang F niya is no. Tama. So, mali, 0.02 pala yung F dito. So, 0.0 to. So, ulitin natin. 0.02. So, the Q1 is 1.95 cubic meter per second. So, ang F2 natin ay 0.025. L, ang length natin ng 2 is 1,000. Q2 squared over, ang diameter natin for 2 is 450 mm. So, ang Q2 natin is equals to, so, bali yan, 6.59 times 0.45 raised to 5 over 0.0826 times 0.025 times 1,000. 0.237. So, mukhang so, ulitin ko lang ba? Parang hindi ko na na-square ito eh. 62.41 times 0.6 raised 5 over 0.0826 times 1,500. So, yeah, hindi ko nga siya na square root. So, the correct answer is 1.4. So, yan, alam natin na Q1 ay sinusupply niya si Q2 pati si Q3 kasi ang ano natin, ang junction natin ay mas mataas sa elevation B. So, Q1 equals to Q2 plus Q3. So, makukuha natin yung Q3, bali Q2 at Q1 na 1.4 minus 0.237. So, Q3 equals to 1.4 minus 0.237. 1.163 cubic meter per second. So, it's for Q. So, hanapin lang natin yung ano niya, HF3 equals to may properties naman yung pipe, 0.0826. Ang F niya is 0.018. Then ang length niya is 900. Then Q niya is 1.163 squared over, ang diameter niya is 0.5. So HF3 is equals to 0.0826 0.018 times 900 times 1.163 squared over 0.5 raised to 5. So we had 57.9192 ang HF3. So nakakuha natin yung elevation ng C. So ang elevation ng C is equals to 870.59 minus HF3 na 57.9. And that is 812.67. So that's the answer for sample number 1. Sample for type 1 problem of reservoir. So, move na tayo sa type 2 problem, no? Yung reservoir. So, type 2 problem. So, for type 2, so huwag na nating aralin yung long process niya. Direkta na tayo doon sa Caltech. Kasi alam ko naman na alam niyo na rin naman to. So, the reservoir pa rin. Then, A, B, C. So, elevation A, elevation B, then elevation C. So, ang mahirap kasi dito, di ba, i-prove mo pa kung saan yung papunta yung flow. So, kaya, mayroong case 1 yan, tsaka case 2. So, for case 1, Q1 is equals to Q2 plus Q3. Then, for case 2, Q1 plus Q2 equals Q3. So, yung caltech nito, actually, na-derive din siya sa formula na yung head loss. Kasi pag ang head loss formula ay let's say yung coefficient na ito, nilagay mo na A, Q squared. So, ang head loss, diba? Ang head loss niya, let's say ganyan ang nangyari. Let's say ganyan yung nangyari for case 1. So, ang head loss niya for HF1 equals elevation A minus minus yung papalagay mo na X. So, bali kaya, ang naging caltech niyan, lumabas sa caltech ay yung ganyan na X over A is equals to elevation of A minus elevation of B. Minus X over B. So, plus, yan, elevation of A minus elevation C minus X over C. So, ganyan lang yung equation natin for calculate. Then, after yung lumabas yung X, papalitan nyo na lang ng tutuldok yan. Lalabas na lahat ng kimo dyan. So, for case 2, mapapalitan lang naman yung C ay mapupunta dito, then yung A ay mapupunta din doon. So, parang ganyan na siya. Square root of X over C equals square root of elevation A minus elevation elevation A over elevation C minus X, di ba? Over A. So, same case here, elevation B, elevation of B minus elevation of C minus X over G. So, ganyan lang siya. So, for a sample problem, store na lahat ng data. So, makakuha na natin lahat ng sagot. So, alam ko naman na alam niyo na to. So, hindi ko na siya di-discuss. Mahaba. Kasi nung tinignan pa yung diagnostic nyo, halos actually lahat ata nyo nakakuha yung problem. So, that's all for reservoir problem.